Kia ora. In the STAT193 video, you're going to learn to use your graphics calculator to calculate normal probabilities. This is the context we're going to be using for the questions. A questionnaire designed to measure the social connectedness of a person contains a sequence of questions about their life situation, family, work, and friends. On the basis of the responses given, a connectedness score can be calculated for that person, with a higher value for the score indicating greater social connectedness. When the questionnaire was administered to students in the USA, the scores were found to follow a normal distribution with a mean score of 3.10 and a standard deviation of 0.67. In the first question, we're being asked to find the proportion of students in the USA that have a score greater than 4. Whenever we're given normal distribution problems, we should start by drawing the normal distribution curve and labeling on the information we know and what we're interested in. So we label on the population mean of 3.10 as the centre of the curve, and we're interested in scores greater than 4. So we label on 4. We want to know about scores 4 and higher, so we're interested in the area that's to the right of 4. This shaded area is the proportion of students with a score greater than 4. We now go into the stat menu of our graphics calculator. We choose F5 for distribution. We've got a normal distribution curve, so we go to F1. And because we're interested in a proportion or a probability, we go to NCD. We check that data is on variable, and if it's not, we select F2 for variable. We now need to enter the lower and upper limits of the shaded area here that we're interested in. So the lower limit is 4. For the upper limit, we've got nothing labelled on our curve, so we need to recall that a normal distribution curve goes to positive infinity on the right side and negative infinity on the left. So what we're going to do for the upper limit is enter a really large positive number. So 9 exp 99 means 9 times 10 to the power of 99. We then need to enter the standard deviation and population mean from the problem. So 0.67 and 3.1. And we can execute that. And that gives us a probability here of 0.0896 to 4 decimal places. We can report that there. If I just exit out of this for a moment and back to the screen where we entered the data and arrow down, I can click on F6 draw and it will draw the normal distribution curve with the area that I've told it we're interested in. And this is just a good way to check that this diagram here matches this one here. So just to say that I have actually entered the correct information. Okay, if I exit back out of that and come to here. In the second problem, we're being asked for the probability that a student in the USA has a score less than 2. So again, start by drawing the normal distribution curve, label on the mean. We're interested in scores less than 2, so we label on 2, and we're going to shade the area to the left this time for 2 and smaller scores. Okay, again, this shaded area represents the probability that we're interested in. We check that data is on variable. Now for our lower limit of the shaded area, we want to enter a very large negative number. So negative 9 exp 99, which means negative 9 times 10 to the power of 99. Execute that. Our upper limit of the area we're interested in is this 2 here. The standard deviation and the mean haven't changed in our problem, and the calculator remembers it from the last problem that we've done. We now execute that, and it gives us our probability up here of 0.0503 to 4 decimal places, which we can report here. It also, if we need it, gives us our z-scores associated with this area. Okay, in the last problem, we're doing something slightly different. We're trying to calculate the values that the middle 80% of students in the USA score between. So we start off in a similar way. We draw our normal distribution curve, we label up the mean of 3.10, but now we're actually being given a probability, this 80%. Okay? We're trying to find the two numbers, x1 and x2, that 80% of students fall between in terms of their scores. In order to do this, if we exit back out of here, we go into distribution again, normal distribution, but now because we've been given the probability and we want to find the x value, we choose inverse normal, F3. Check that data's on variable and come down, and you now need to select the tail, if it's the left, right or central tail. So let's take a look at our diagram. We've shaded in the central 80% of this curve. So we're interested in the central bit. So we can enter that. If we come down, the area is the probability. So we've got a probability of 0.8, which is our middle 80% of students. Standard deviation and mean are the same, and it's remembered that from our previous problems, so we can execute that. This now gives us the x1 and the x2 scores. So the score x1 here is the lower limit, the score x2 the upper limit, that the middle 80% of students fall between. And we can report that as 2.24 to 3.96 to 2 decimal places.